In this lesson, we're going to be working on solving algebraic equations that are going to involve the combining like terms and the distributive property. In other words, simplifying the equation and then solving the equation. The learning target, I can combine like terms and use the distributive property to simplify algebraic equations so that I can find their solutions. I will know I've got it when I score 100% on the assignment for this lesson. So we've been working on solving two-step equations. And so we are going to continue solving two-step equations, but we have to first get them into that format of a two-step equation. Remember, a two-step equation is an equation that has two different operations involved. So we're looking at this equation, and I can see that there's subtraction and addition, which are considered the same operation in the same family. So that's one operation. But we also have this multiplication piece with these coefficients 9 times b and 5 times b. So these are two-step equations because they just have those two different operations involved in the equation. But it's not in the two-step format to start solving. So the first thing we always want to do when we're solving equations is see if there's any work we can do to first simplify the equation. And in this situation, it would be combining like terms. So we can look for that where we can combine things together, add or subtract. And then in this case, there are like terms here. So I have this term right here. I have this term right here. And I have a third term. But these two terms can be combined because they both have that same variable raised to the same power. So we can go ahead and do that subtraction, 9b's, and I'm going to take 5b's away, so I end up with 4b, and then my plus 18. So if there's anything you could add or subtract before solving, that you want to do, simplify first. Now we're into the point where there's no more we can do. We can't combine the 4b and the 18 because they're not like terms. The other reason I can justify not combining those is order of operations would say we have to multiply this first before we can add, GEMDAS, multiply before addition. And we don't know what b is, so we cannot multiply that. So we can no longer go any further. So it's in its simplest form. And now I'm ready to solve. When I solve, I like to draw that line down the equal sign. I like to identify my term that has the variable in it. Oops, I'm not in scribble mode. So I circle it, and then I isolate. I need to isolate this term right here, so I'm going to do inverse operations. I need to get rid of the plus 18, that's minus 18. And I have to do it on both sides. Remember, the goal when we're solving algebraically is to isolate the variable term first, and then keep the balance. How you isolate it is subtracting the 18. And then on this side, when I subtract that 18, I'm going to get that solution to the equation. So it serves two purposes, that subtracting 18. One, to isolate the variable term, and on the other side, to find your solution. So when I do the math that I just wrote, 4b plus 18 minus 18, these cancel, and I get 0. And the only thing left on this side of the equation is the 4b. On the right side of the equation, when I do that subtraction, I just borrow here, and I get a 6, I get 56. Now I'm going to circle my variable because I've now gotten it down to a smaller equivalent equation from what I started with. And I need to isolate b now. So to isolate b, I have 4 times b. I'm going to do the inverse operations. I'm going to divide by 4 on this side, so these cancel, and I get 1b, which is just b. And on this side, I'm also going to divide by 4. Use that fraction bar, don't use this symbol. Don't like that in the algebra world. Use that fraction bar, and I get 14. Okay, now we just have to run a check, so I'm going to come over here. I'm going to make sure I didn't make any mistakes when I was doing my simplifying and solving. So I'm just going to go 9 times what my solution, what I think it's supposed to be, 14. I'm going to replace b in both places with 14. And I'm just going to rewrite the entire equation, but I'm going to take that b out and put in 14. so that I can then see my order of ops to funnel this down. That's supposed to give me 74 if I did it correctly. So when I multiply this together, I get 126. When I multiply this together, I get 70. And then add 18. So I'm following order of operations right now. I have 3 terms. This one needs to be simplified. This one needs to be simplified. And then I've got my 18 that's already simplified. So I'm just funneling it down. Now I'm going to do 126 minus 70. When I subtract that, I end up with 56 plus 18. Remember, this is supposed to give me 74, and I just keep funneling that left side, bringing down the 74, so when I'm done, I can see if they match. When I add 56 and 18, I get 74, and it worked. So I did find the right solution. The solution is 14 for this equation. All right, here is another example. And in this example, again, we're trying to, this is a 2-step equation. It's got multiplication and subtraction involved in it. So but it's not in that ready to solve format for a 2-step. So we need to do some simplifying first. And when I'm looking at this side here, I've got one big term right here that can be simplified out. So one way you could do this is the distributed property. We can't combine, we can't follow order of operations to simplify because we cannot subtract 4 from 2j. Order of operations said we'd have to multiply before we can do the subtraction. We don't know what j is. So that means we can't do this inside. And then on the outside, I have this 3 times the quantity. So what allows us to keep going and to keep going with this problem to try to change its format is the distributed property. So I can distribute the 3 to both parts, 3 times 2j minus 3 times 4. Draw that line down my equal sign. And that should get me 24. So now I can multiply these numbers together. I'm just going one step at a time to make sure I'm understanding each piece. And now I get my, my one term into 2 separate terms. And now it's in that 2-step format ready to solve. So to solve this, I can now go 6j minus 12. I need to circle my term with the j in it. So I can recognize to get rid of that minus 12. And I can get rid of that minus 12 by adding 12 to both sides. On this side, it will get me to isolate this term by itself, shorten the equation, get closer to the solution. And on this side, it gives me part of the solution. Okay, so I just draw my equal sign in, and now I do the math that I just wrote. 6j minus 12 plus 12 simplifies into 6j, and 24 plus 12 is 36. And now I'm going to circle my variable because I need to isolate it. I need to get that by itself, and I'm multiplying by the coefficient of 6, so I'm going to divide by that coefficient. And then I'm going to simplify the division I just wrote. 6 divided by 6 is 1j. I'm isolating that j. And on this side, 36 divided by 6 is 6. So now I want to make sure I did it correctly. So I come over here. I'm going to plug in what I found for j, which is 6. So I substituted that in. And I'm suggesting that when I plug that in, I should get hopefully 24. And now I do the math. I follow order of ops. I can use the distributed property, but it'd get messy because I can do everything that's inside these parentheses. There's no missing numbers. So I'm just going to funnel order of ops to GEMDAS grouping symbols first. Inside I have multiplication and subtraction. Multiplication comes before subtraction. So 12 minus 4. And now I just simply do the subtraction. I can drop the parentheses and I get 24. On this side, every row of work I do on this side, I'm going to bring that 24 down to just show that funneling on both sides. Since there's no math to do on this side, I can just carry it on down. And then the last step, they should be the same if I found the right solution. And the solution that I found was 6, and it did work. Okay, in this problem, we have a couple of things going on. There are just two operations in this problem. We got this multiplication piece and addition. So it is a two-step equation because it has two different operations. But I have to simplify this out so it's in that ready-to-solve format. So when I'm looking at this, I have two terms. I have this term right here, and I have this term right here. So I can't do anything with this term G until I clean up this term here. So I try to add what's inside the parentheses to simplify, and I cannot do that. So I'm now going to apply the distributed property to get rid of those grouping symbols. All right, so I'm going to multiply through those parentheses like so. And when I do that, I end up with G plus 3G plus 3 times 4. I'm going to break it. I'm going to write my computation before I actually do it. And I'm suggesting that that new equivalent equation to the one above that I'm trying to get in a simpler form is equal to 20. Trying to find that solution that's going to make this side 20. Now that I got that done, I can look to see if there's anything else I can do. Well, I can multiply that together and I can add these like terms together. Remember, this is 1G. So I have 4 G's on this plus 12. So I'm just going to combine like terms where I can, do my addition where I can, and multiply that 12 out. Now when I'm here, I cannot combine these because they are not like terms. And I can't multiply this because I don't know what G is. So I'm in its simplest form, and now it's ready to solve once I get it all simplified. So I'm going to start by circling my term with the variable in it. That'll help me see that this needs to go away. So I'm going to subtract 12 from both sides. I'm going to put my equal sign in underneath. There it is. And then this goes away, that makes 0. 4G plus 12 minus 12, well 12 minus 12 is 0, so I'm left with 4G on the left side, which was my goal, to isolate that 4G. And on the right side, I'm getting closer to the solution. I'm whittling it down, I got 8. Now I'm going to circle my variable, because that'll help me decide how to get rid of that coefficient. It's a 4, so I'm going to divide by 4 on both sides, keeping that balance. Okay, and then on the left side, it's going to isolate G because I'm going to get 4 divided by 4 is 1. And 1G is just G. And on this side, it gets me my solution. 8 divided by 4 is 2. And once again, we should check to make sure that we found the right solution. So I'm just going to draw a line down the equal sign. And I'm going to plug in what I think the solution is, which is 2. I plug it in everywhere there's a G. There's a G in 2 spots. So I do 2 plus 3 times 2 plus 4. Does that give me 20? That's what I'm trying to figure out. And if it does, I've got the right solution. Okay, on this side, I'm just going to funnel my work. I can add what's inside here, so I'm not going to use the distributed property. I think it's just quicker and easier just to add because I can. So I don't have any unknowns. And I'm wondering if that's going to give me 12 or 20. And I get, whoops, I made a mistake up there. That should just be 6. I don't know where I got that from. 6. It's working ahead in my brain, I guess, because there's the 18. So I got 3 times 6 is 18. And I'm funneling down some more, and then I get 20 equals 20. It worked. So my solution that worked for this equation is 2. Okay, on this one I'm going to help you get started, but then I'm going to have you finish on your own with the solve and the check. Okay, we're going to start first by just identifying the terms so we can see what kind of cleanup we might need to do before we have to solve. So I'm circling that, and I'm circling this right here. And first term is 8, the second term, remember terms are separated by the pluses and minuses that are not in parentheses. Here's my second term. And I need to clean this one up. So I'm going to need to use that distributed property here. All right, once you get it cleaned up, then you're going to want to look to see if there's any addition and subtraction you can do. And then once you get that cleaned up, you start solving. So you're going to keep going on this one. Turn the video back on when you're done to see if you did it correctly. All right, so you should have gotten 5 as the solution. You should definitely go through and check your steps, each row of work against my row of work, to make sure that we are following the pattern there for solving, isolating the variable on the left and finding the solution on the right, and organize the rows. And then your check, you should have first plugged the number in the first row, and then followed order of ops by doing one operation at a time. 5 minus 1, 6 times 4, and then finally addition last, 8 plus 24. On this side, you just keep bringing this 32 down. For every row of work you did over here, that 32 comes down to compare against it until finally you can see they are the same. Okay, our last example, I'm going to get you started again by identifying terms. That's kind of a key to simplifying correctly here, because if you mix up the simplifying, then your solving isn't going to probably work either. So we have terms are separated by the pluses and minuses that aren't in parentheses. So this is a 3-term equation, but it's really only a 2-step equation when it comes to solving, because there's only multiplication and then addition and subtraction are considered equal operations. So you have only 2 operations here. Okay, so there's this term in the middle has to be cleaned up. 7 is already set. This one has a multiplication and subtraction going on. And then this term is all cleaned up. It's just waiting for this middle one to be cleaned up. When you look at this middle term, you try to follow order of operations to get it simplified. You cannot do a minus 1 because you don't know what a is. But we do have that distributive property that you can apply here. So you're going to want to start with the distributive property. Once you get that cleaned up, then you look to see if there's anything you can add or subtract, and you clean that up. Once you get both of those done, you should be ready to solve that solution, or solve for that solution using inverse operations and balance on both sides of the equation. Then when you're done, you're going to come over and you're going to run the check on it to make sure you found the right solution. And if you got it correct, you can then watch and check your rows against mine to make sure you're showing your work in that algebraic fashion. Neat rows, keeping balance, all that good stuff. So pause, work them out, and then turn it back on to see how you did. Okay, so you should have used the distributed property, and that gets you row 1, and then you clean row 1 up here, and you have row 2, 7 plus 2a minus 6. The 2a came from combining these like terms, 6 a's take away 4 a's, and the 6 came from 6 times 1. Then you have to do your combine these terms, 7 take away 6, which is 1. That's where the 1 came from. And then you subtract 1 from both sides. After you identify 2a, you need to get it by itself. Now you're ready to solve here. So you subtract 1 from both sides. Then you circle your a, and you just have to get a by itself by dividing both sides by 2. And 15 divided by 2 is a decimal 7.5. So we go up here, and wherever there's an A, it's 2 spots. We replace it with 7.5. So row 1 is simply substituting in, doing no math. Row 2, I follow order of ops. I subtracted 7.5 minus 1 and got 6.5. And I multiplied 4 times 7.5 and got 30. Next, I multiplied 6 times 6.5 and got 39. Then I just worked left to right, and I did 7 plus 39 is 46. Take away 30 is 16. So just funneling on this side got me 16. Every time I did a row of work on the left, I just brought that 16 down on the right, so that when I was finally done simplifying, I could see they came out the same. So I did find the correct solution, which is 7.5. Right. So when you have these more complicated looking equations, you just first have to look to see if there's any way to simplify the equations, either following order of operations or the distributed property, if you have those grouping symbols where you cannot do what's inside of them. And combining those like terms. Once you have that done, it should look like a two-step equation that's ready to be solved. And you use that inverse operations on both sides of the equation to keep that balance in order to isolate your variable and get the solution on the other side. Once you have your solution, substitute it into the original equation, follow the order of operations to make sure that both sides of the equation come out to the same value, and then you know you've done it correctly. Good luck on your assignment.